calculate concentrations because we're going to need to know how to calculate concentrations and use concentrations in our equilibrium formula or our KEQ formula. You have probably heard concentrations used before. Lots of times they'll say so many grams per liter, or they'll say moles per liter, or moles per milliliter. You've also probably heard of parts per million, parts per billion, stuff like that. Most often in chemistry, we're using moles per liter. Okay? But basically, concentration is the amount of solute divided by your amount of solvent. Do you guys know the difference between solute and solvent, or do you remember the difference from solute to solvent from like back in the day? Solute is like what you dissolve into. So like the iced tea crystals, not what you dissolve into, what you dissolve. So iced tea crystals. Back in grade 8 science, I remember talking about the water and the iced tea with you guys and the concentration. Concentration gets stronger when you add more solute and you add more iced tea crystals, right, than you're supposed to. They get stronger in concentration. You get weaker concentration when your grandma makes it, or, no, I shouldn't say that. Do I have to go talk to Grandma Pat? Okay, because they add less solute, right? So they add less solute, or they add more water, right? So your concentration is your amount of solute divided by your amount of solvent, okay? But lots of times in chemistry, we deal with moles because moles are equal across. Remember when we did our conversions and we're like, we have this many grams of this substance, how many of this grams are stoichiometry, right? Of this substance did we make? We had to go into moles and then do a mole-to-mole conversion, right? So we like to keep things in moles because of the fact that you can go from one substance to the next. So a lot of times our concentrations, can I flip the page? Our concentrations are in something called molarity, okay? And molarity is moles per liter, okay? So you find the amount of moles you put in. Sometimes they say, we dissolve 5 grams. Why would they say we dissolve 5 grams? Because that's how we measured. Even on the, like Monday, we measured in grams and dissolved it in so many liters of water. But if you watch the video, they said they took 5 moles per liter, 5 molarities, or 5 M's of this stuff, and 6 moles of this stuff, molarity of this stuff. In order to actually make a solution, you have to figure out how many grams you're going to put in, because that's how we measure in our lab. So you have to be able to convert from grams to moles and moles to grams still, which we know how to do, because we've done that already, right? Moles to grams or grams to moles. So now, maybe, I deleted that. Yeah, molarity. I don't think you really need to write all of this stuff. You need the formula, and you need to know that this symbol here, sorry, it's a little bit off. The symbol M stands for moles per liter. Stands for molarity, okay? And to get a molarity, you're just basically taking the amount of moles of that substance, dividing it by the amount of liters that are there. Sometimes they'll give you how many milliliters you added. Do you know the conversion from liters to milliliters and back? How many milliliters are there in 1 liter? 1 liter contains 1,000 milliliters. Okay? So if I had 100 milliliters, how many liters do I have? Well, 100 divided by 1,000, so it's 0.1 of a liter, right? And And of course, with all chemistry calculations come significant figures. Yeah, sig figs. They got to become your buddy. You got to be good at sig figs near the end of this chemistry course. Okay? So basically, you need this formula, and you need that the unit capital M is written behind, and that unit capital M means moles per liter. Are you ready? Sorry. Okay. Where we're going to go next is we're going to do an example. So what I'll do is I'll pull it up and I'll have you write down the question, and then we'll go through how to solve it. Okay? So, in our example, we are calculating the mass of, what's that, sodium sulfate in 1.6 liters of a 2.5 molar solution. Okay, so capital M, we usually say molar, which means moles per liter. What are we given? We're given a volume, and we're given a concentration in M. So what can we find using this formula? We are given a concentration, and we are given the amount of liters. We can find the amount of moles. Is that what the question asks? What did the question ask? It asked for calculating the mass, so grams. But if we know the amount of moles, can we calculate the amount of grams? Yeah, by using an old school method. What's wrong? Okay. So, basically, determine the number of information. I wouldn't write this down. Some people write it down. I usually write little things on the side notes. You guys remember me solving questions, writing the main pieces of information down? This is the main pieces of information. That you're dealing with sodium sulfate. Your molarity is 2.5 moles, and your volume is 1.6 liters. We know we have to solve for moles, and then find the amount of grams. So this is me saying, hey, what do we need to find? Well, we need to find the mass, so we need to find the moles first. Okay, this is me really stepping it out, going the first time going through this, okay? Do I expect to see required information? Information given, written down? No, but I could see your side notes there, right? I've got this and this, okay? So let's solve using that formula. So you guys ready? M is equal to your concentration, no, it's equal to your moles over your liters, right? We know that our moles are 2.5 moles per liter, a molar solution. The moles is what we're trying to find out, and the amount of liters, what was the amount of liters that we had? 1.6, right? Okay. How are we going to solve this? Okay, we could cross multiply. We could make this over 1. Neither do I. Okay. That's okay. Thank you. So we can cross multiply, and we can make it over 1, right? Some people will say, hey, look, this x, if we just multiply by 1.6 liters, the 1.6 crosses out. It's the same thing as cross multiplying, right? So I multiply by 1.6 liters. You guys have to be a calculator for me today. We carry all the decimals through, or I can be a calculator for myself, I guess. 1.6 times 2.5 gives me 4. Exactly. All right. Now, what unit do I put in there? Okay. What does capital M mean? Capital M means moles per liter, right? And if we multiply by liter, liters on the top and on the bottom, so you're left with just moles. So we have 4 moles of Na2SO4 sodium sulfate. But that's not the question. That's not what the question asked. The question asked us how many grams, right? So what can we do? Well, we can go old school, right? We can say, well, I have 4 moles of Na2SO4. I want to know X grams of Na2SO4. Special number for moles is 1. Good. How do we figure out the special number of sodium sulfate? Okay, so sodium is 22.99, so 2 of those, plus 1 sulfur, 3207, plus 4 oxygens, 4 times 16, to give us a total of Thank you. Sorry. How did we get that number again? We took 2 sodiums, 1 sulfur, 4 oxygens off your periodic table of elements, your green one, right? Their atomic mass. You added them all up. We got that. The last thing we have to do then, times by 4. So 4 times 142.05 is so going back to the top, we have 2 sig figs in the 2.5 moles or molar solution, right? So 2 sig figs. So if we wanted to actually do this in 2.6 liters, sorry, 2.5 liters, 1.6 liters, I got to remember my question. I would have to weigh out 570 grams of it and put it in to make a 2.5 mole solution. Is this okay? So we learned a concentration formula. The concentration formula is basically concentration is equal to moles divided by liters, and that gives you a concentration value that we call molar, right? This many molar solution. So, next question. The concentration of 515.2 grams of aluminum chloride in 500 milliliters of water. How do we figure out the concentration? And I'm going to tell you guys this. You could do concentration in grams per milliliter, grams per liter, but in Chem 30, anytime I just specifically ask for concentration, it needs to be in moles per liter. Okay? So we have to make sure that we're putting this in moles per liter when we do this. Are you guys ready? What are we given in this whole question kind of sheet? Sorry, what are we given in this question? So, what are we actually given? We're given that we have 515.2 grams, but we actually have to write aluminum chloride in its proper form. Aluminum chloride is an ionic molecule. What's its formula? Aluminum is a +3. Chlorine is a, so how many chlorines? I need 3 chlorines for every one aluminum. Aluminum's a +3, chlorine's a -1. So I have to write that formula down. Why is it important to figure out the proper formula? Because if you don't have the proper formula, you won't be able to calculate the proper number of moles, right? We're also given 500 milliliters, which we're going to write it as 0.500 liters. Why would I change it right to liters? Because the formula in concentration, you guys, we need in liters, right? So how did I change 500 milliliters into liters? I divided by 1,000, right? Because there's 1,000 milliliters per 1 liter. So what are we actually trying to find out? We're trying to find out concentration. And just so you know, when we write square brackets like that in chemistry, that means the concentration, okay? So what's the first thing we have to do if we have to calculate the concentration of this stuff? Figure out how many moles of aluminum chloride we actually have. So I know I have, 515.2 grams. And I need to know X moles of aluminum chloride. Special number for moles is 1. Special number for mass. Well, what is the mass of aluminum? What is it, 35.45? No. Aluminum's 35.45. What's chlorine? Oh, this is chlorine, 35.45. 2698. I do the math, I get 133.33. I can't listen and write at the same time. I'm sorry. So this is a cross multiplying, but really x over 1 is just x. So basically we do 515.2 divided by 133.33, and we get, did anyone do that? 515.2 divided by 133.33 gives me 3.84. 3.864. Now, remember, remember when we're carrying on calculations, we have to carry those decimals through. So even though I wrote 3.864, this is what, moles of aluminum chloride. When I carry on to my next step, I'm going to carry all those decimals. Okay, so now I know moles. Can I calculate concentration? Okay, so I'm going to write concentration of aluminum chloride is equal to 3.864 moles divided by 0.5 liters. Now, basically doubling it when you're dividing by half, so we divide by 0.5. Notice I carried all those decimals, and I get 7.728. Okay? 7.728. And this is moles per liter, so I can write it as capital M as molar. How many sig figs though? If we go back up, 500 milliliters was only 1 sig fig there, right? This is milliliters, but this is me specifically writing. In the original question, there's only 1 sig fig. So we always go with the original question. Lots of times when you're measuring the liquid, you measure to the 10th of a degree, so you'll probably have 4 sig figs or 3 sig figs, usually when you measure using a graduated cylinder. But in this question, it's only 1 sig fig, so our answer is the concentration of aluminum chloride is 8 molar solution. Okay? Now, I feel like that's probably all I need to do for examples. I feel like you're okay with that. There's one more type of things that we can do. Because you guys know that I can take acid out of my acid cupboard or base, right? It's in liquid form already. It's in usually 18 molar solution, or I have like 1 molar solution or 6 molar solution, and we can add water to that. When we add water to that, what happens? It decreases the concentration. It dilutes it. Okay? So there's one more formula. This is the dilution formula. We should actually write dilution formula on top of it. So the concentration before times the volume before is equal to the concentration after times the volume after. I usually don't even put an X in there because we know from math class if they're written right next to each other, that means multiply, right? So the concentration before, it's written too fast, times the volume before is equal to your concentration after times your volume after. Okay? You don't have to draw the chart and then draw what I wrote. It depends on who you are. Some of you need to know what CB and VB mean. Some of you already have that memorized, so it's up to you what you put in your notes. But you definitely need to be able to use this dilution formula. I think we have these formulas. The very front pink sheet. You have concentration equals moles per liter, or capital M, molarity, amount of solute, volume of solution. And then you even have this formula. They have C times V equals C2 times V2. They don't use before and after. They use 1 and 2 on your pink sheet. They also do it with moles and volume. Okay? So you can have M1 times V1 equals M2 times V2. That's the same kind of thing. They even show you how to do a calculation of moles right underneath that. Okay? So, let's say I take 12 molar solution. So let's do an example. If I take 12 molar solution of hydrochloric acid, I'm going to take 100 milliliters of it. I'm going to add 900 milliliters what's my new concentration? So we have 12 molar solution. What would that be? CB or CA? Is your concentration before. So I'm going to say my CB equals 12 molars. What else do we know? Do we know our volume before? We have 100 milliliters. Do we know our concentration after? No, but that's what we're trying to find out, right? So Ca, I can put, and then volume after is equal to? Good. This is where mistakes get made. How much did we have? We had 100 milliliters. Then we added 900. So our volume after is actually 1,000 milliliters. Some questions will tell you how much they added, and someone will say to make up a total volume of 1,000. So you have to be careful, because sometimes the number there is the volume after, and sometimes the number there is the volume that they added. So you have to add the volume before, that to the volume before, okay? So just be cautious with how it's written. After that, you guys, because you have concentration times volume equals concentration times volume, we can leave these volumes in milliliters. As long as the volumes are both in milliliters, you can leave them in milliliters. Or you can change them both to liters. It really doesn't matter. But as long as the concentrations are equal to each other, or are the same unit, and the volumes are the same unit. So when I go calculate my concentration after, I know I'm going to end up with moles per liter, because that's what my concentration before was in for the units. So concentration before times volume before equals concentration after times volume after. 12 mole per liter times 100 milliliters is equal to concentration after times 1,000 milliliters. So how do you solve this? We're going to divide by 1,000. By 1,000 or 100?
I went 1,200.
Okay, so you got this as 1,200 moles times milliliters, right? Because really, you multiply the units too, right? Just like we multiply anything, you have to multiply your units. So on this side, we get 1,200 molars times milliliters is equal to my concentration after, and then I'm going to divide by 1,000 milliliters. So then your milliliters will cross out those units, and that's why I said it's okay to leave them in milliliters as long as they're both in milliliters. Another way they trick you with questions, or I trick you with questions, I guess I should say, is I put one volume in milliliters and the other volume in liters. You have to have the volumes the same. So 1,200 divided by 1,000 is 1.2, right? We have 1 sig figs, 2 sig figs. Is that all I made? 1.2, oh, I never, my 100 milliliters. If I would put this, let's put that. Let's put a decimal behind the 100. Sorry, I just read Kelly's answer. If I put that decimal there, it's 2, 3, and 3, so my answer should have 2 sig figs. So 1.2 moles of, and we really should get used to writing of what we made, of hydrochloric acid. Okay? So, we have about 23 minutes left in class time. I have 11 questions sitting here. We're going to play roll the dice. We're going to roll 2 dice. Whatever the 2 dice adds to, you have to complete that many questions. Okay? Then you do 11. That's where you luck out. If it turns out to be 12, we'll do 11. Okay? Here's the dice. Drum roll. This tells you we're rolling 2 dice. However many it adds to. Whoa! Okay, go. Roll the dice.
You roll high numbers. Roll snake eyes.
That's how many questions you have to do of this stuff. Does it do? Our lucky 56. There's four. 6 questions. Okay? So, no, I did cut it in half. 11 divided by 2, that's like 5 and a half. So that's 6. No, they got to do something on their break. We have 6 questions. So let's do 1, 3, 5, 7, 9, and 11. That makes 6, right? Odds. So odd questions. Oh, you guys, I forgot. Oh, I am recording. Oh, good.